All right, we are still in Chapter 7 here, Section 3, titled Triangle Similarity. Notice the abbreviations, AA, SSS, SAS. And you should remember from the congruent triangles chapter that those stand for angle, angle, side, 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 and side, angle, side. But there's one big difference because we're in a similar triangle chapter. This reads, there are several ways to prove certain triangles are similar. The following postulate, as well as the SSS and the SAS similarity theorems, will be used in proofs just as SSS, SAS, ASA, HL, and AAS, those are all on the poster above my smartboard, were used to prove triangles congruent. But remember, we're talking about similarity now. This first postulate is the AA, which reads, if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. In other words, we only need two angles. Two angles congruent. We don't need to know the third angle. As long as we have two angles, then the triangles are congruent. So, look at the next slide. Explain why the triangles are similar and write a similarity statement. If you look at these triangles that are connected here, I see angle A and angle D are right angles, so those two are congruent. But also remember vertical angles. That would be this angle here and that angle there. Those are vertical angles. So I have the two triangles congruent. Why are they congruent? They are congruent because of AA. Now, we have to now write a similarity statement. And all you do is this. You write triangle. Let's say triangle on the left, ABC, is similar to triangle, and let's match this up. Angle A goes with angle D. Angle B would go with angle E. And angle C, of course, is going to be the same. So make sure your three letters are in the appropriate order. Look at the next one. Same thing. Explain why the triangles are similar and write a similarity statement. Well, I see angle B and angle E are right angles, but I see a 43 and a 47, not congruent. But remember the rule of 180. If you subtract 43, wait a second, not 180. These two other angles are 90 and subtract 43. That gives you 47, which means this. Angle C is 47, and angle D then would be 43. So we do have angle, angle. Those triangles are congruent because of angle, angle. Let's now write my similarity statement. And I'll do the first triangle. Let's call it ABC. Is similar to triangle, and let's match this up. Angle A goes with the other angle, angle D. They're both 43. B goes with E. And C then would be the F. There's my similarity statement. Next slide. This now, side, side, side. But there's a key word I want you to circle. The theorem reads, if the three sides of one triangle are proportional, which means two proportions or two ratios that are equal, we would solve that by cross multiplying. It's not equal. The sides will not be equal. Only the angles are equal. Sides are proportional. So if we have all three sides in proportion to each other, We have similar triangles. The next one is now SAS. And this one reads, if two sides of one triangle are proportional to two sides of another triangle, and their included angles are not proportional, but rather congruent. Angles have to be congruent. Sides have to be in proportion to each other. That's the SAS, or side angle side. If you look at this slide, verify that the triangles are similar. I have no information about the angles, so I'm going to try to prove this by using side, side, side. So let's set up a proportion. I'm going to start with this 2. It corresponds to, the other one's upside down, 3. So I'm going to write 2 over 3. That has to equal, maybe this 3 goes with that 4.5, again, because it's upside down. 3 over 4.5. Now let's cross multiply that. What's 2 times 4.5? 9. The other direction, 3 times 3 is 9. So are they in proportion to each other? Yes. Are those two triangles, are they similar? Yes. Why are they similar? Because side, side, side. The three sides are in proportion to each other. Next slide. Verify that the triangles are similar. Well, I think I'm going to use side angle side, because I have this 70 and that 70. So I have my angles taken care of. They're congruent. Now let's check to make sure my sides are in proportion to each other. So this 2 corresponds over here to this 1. So I'm going to write 2 over 1. And then 5.8 corresponds to 2.9. So I'm going to write 5.8 over 2.9. Cross multiply. 2 times 2.9 is 5.8. And of course, the other direction, 1 times 5.8 is 5.8. So yes, they're in proportion. Are those two triangles similar? The answer is yes. Why are they similar? Because of side angle side. One more slide, and we'll be done. Now, the diagram we have here, those are called overlapping triangles. And I always encourage you to draw them separately. So here's the first one. Just do my best here. There's the second one. So the one on the left would be A, B, E, and then the big one would be A, C, D. And you can fill in your right angles and then fill in your numbers now. AB would be 9. B up to E, that'd be a 5. Now from A to C, you have to write 9 plus 3. That'd be a 12. And that would be an X, which we're going to solve for here in a moment. Do I have any angles that are congruent? This angle A is a shared angle. So I can put an arc mark there and an arc mark there. So my first question is, are the two triangles similar? The answer is yes, because of angle, angle. I have two angles that are congruent. Now we have to find CD, which is, in other words, find X. So let's write a proportion. We're going to cross multiply here in a minute. I'm going to start with the X and go to the other side. It looks like that's going to correspond to that 5. My next ratio, to keep my pattern the same, would be this 12. Put that on top. Corresponds to this 9. So we have x over 5 equals 12 over 9. Cross multiply. 9x is 5 times 12, that's 60. Divide by 9, and that comes out to be about 6.67, or 6 and 2/3. And that would be your answer. Hey, good luck on these. Thank you for watching.